Hello everyone, I'm Jack Rilan. So for today's video, we will tackle about the other concepts related to plant growth. So first, we have the law of minimum. So what is the law of minimum? In the 19th century, the German scientist Justus von Liebig formulated the law of minimum, which states that if one of the essential plant's nutrients is deficient, plant growth will be poor even when all other essential nutrients are abundant. Instead, it states that growth is controlled not by total originality applied to plant growth, where it is found in the increasing the amount of plentiful nutrients did not increase plant growth, only by increasing the amount of the limiting nutrients, the most scarce, in relation to need, was the growth of the plant improved. We have a 6-stage Liebig's law of the minimum. We have importance of micronutrients. So first, the law of the minimum takes on added importance when fertilizer prices, especially nitrogen and phosphate, its product are high. So this may attempt some growers to reduce or even eliminate applications of micronutrients or secondary nutrients fertilizers such as K-Mag, a source of a balanced potassium, and magnesium and sulfur also. And for the second, but von Liebig's law tell us clearly that if a soil is deficient in, say, Mg, yields will be depressed regardless of how much NPK product you apply. So, such as a course but can be especially considered during periods of elevated prices of NPK products. So let's look at what can happen when a soil is deficient in Mg or S or both, but grower elects to omit these nutrients because he or she on NPK products.
And next, the law of optima and limiting factors. What is optima and limiting factors? Limiting factors are the factors that are not present in abundance. These are the environmental conditions or resources that limit the growth or distribution of an ecosystem. These can be either physical or biological factors, which are identified by the increase or decrease in growth or distribution or population. So next, we have the Blackman law of limiting factors. First, a plant psychologist, Blackman studied limiting factors in the photosynthesis system of plants. He stated that biological factors are affected by a number of factors, but the amount in which they affect the whole process is different. Let us say that plants require adequate amount of water, sunlight, chlorophyll, temperature, carbon dioxide, and chlorophyll to carry out photosynthesis. The scarcity of any of these components will affect the process of photosynthesis. Fourth, the related magnitude of factor is more important than the absolute magnitude. And the last, a factor which is present in less quantity is a limiting factor.
In another, we have the law of diminishing returns. So the law of diminishing returns in agriculture is the classic example of this law. So farmers usually have a finite acreage of land in which they can add an infinite number of laborers to increase crop yields. So however, there is a point where an additional worker produces less of an increase in crop yields that the last worker added. So at this point, the law of diminishing returns has set in and the farm is less efficient than it was before that the additional worker was added. So on, we have manufacturing. So manufacturing is the other production system follows this same logic. Adding workers past a certain number to a factory assembly, dying workers less efficient because the proportional output is less than the labor force. And thus, the enterprise establishing this point, organizations can set proper expectations internally and
According to Jeff Trinidad, he discussed the law of diminishing returns by other organizations. What is the law of diminishing returns? Number 1. The law of the minimum and diminishing returns are generally seen as conflicting theories in plant mineral nutrition. Number 2. In this study, we show how these laws are both necessarily to explain different aspects of the plant responses to fertilizers. Number 3. We applied the law of minimum at the cellular level, determining how the limiting element transforms into product inside plants. Number 4. We verified that under an uneven distribution of the limiting element and its nutritional requirements, the resulting crop models present diminishing marginal returns, being compatible with Mr. law. And last, we observed that the most of the crop models found in the bibliography could be derived from our approach.